that we have this quadratic here, this is not centered at 0, 0. We don't know where the vertex is, but we need to consider how am I going to draw this graph. So what's going to happen to this graph? It's a parabola, but we're going to do absolute values, so it's going to bend the graph at some point. So we need to think of what are some points to consider. Well, again, the most important point to consider here is when our boundary is, or when the inside equals 0. Okay, and we can find that by factoring the inside. So we end up with two numbers that multiply to -8 and add to -2 are -4 plus 4. So then our boundary then is represented at x equals 4 and x equals -2. Those are going to be important boundary points. Those are going to be our reference points. That's going to be where the graph bends. Okay, so I'm just going to put those in here, maybe -2, +4. I should put a vert, and this is going to be equal to 0. So I'm going to plug those in. I get 0 for those. Okay, those are going to be your 0 points because that's where the graph's going to bend. Okay, and then I really should consider the vertex. The vertex is going to be the part that is going to be halfway between my zeros. So remember with our quadratics, the vertex is going to be symmetrical. The zeros will be symmetrically distributed about the vertex. So my vertex is going to be halfway between these. So halfway is going to add and divide by 2. So it's going to be at 1. I'm just going to plug 1 into this equation. 1 squared minus 2 is -1, minus 8 is -9, and then absolute value is going to be +9. So it's going to start drawing these points in. -2, 0, +4, 0, and the vertex is going to be with negative inside, so ends up at +9. Okay, so the negative changed to positive. I should have some points on the outside here, so I'm just going to maybe choose a couple coordinates. X equals -3, x equals 5. These are just kind of symmetrical points on the outside here. And actually, I'm going to plug it into this one. It's a little bit easier to plug into here, so I get -7 times -1 is +7. Okay, so I'm going to end up with +7. I think it's right here. 1, 2, 3, 4, 5, 6, 7. Okay, and when I plug in +5, whoops, that was -3, wasn't it? And when I plug in +5, I'll get the same thing. I'm going to get 1 times +7, which is +7. So there's my coordinates. Now I can probably anticipate what this graph's going to look like, because I know that this is a regular parabola on the outside here. This is my original positive, and then the negative got flipped upside down. So there's my negative. It gives me this W-shaped graph. And again, I can write this as a piecewise function, because I know that although that doesn't exist, it's an upside down parabola for the negative version, and this is going to be the right side up parabola for the positive version. Okay, so inside is positive. My domain, it looks like it's going to be on the outside, so x is less than or equal to -2, or x is greater than or equal to +4. Okay, so it's not symmetrically about 0, but we know that it's symmetrically about the vertex. And the equation then is going to be y equals, well, nothing changes, x squared minus 2x minus 8. But in between here, something else is going on. That represents our negative version. So where the inside is equal to negative, is going to be between 2 and -2. And for that domain, we're going to take the same graph, x squared minus 2x minus 8, and I'm going to just make it positive with that opposite sign. So it's going to then give me this graph, which is essentially the upside down parabola of the original green one. So there it is. There is it written as a piecewise function. Now I should start using the proper notation for this. So as a piecewise function, it's going to look like this. We use these curly brackets. Okay, we state our domain. So x is less than or equal to -2, and x is greater than or equal to 2. It's equal to x squared minus 2x minus 8. Okay, so here we state our negative domain, where in that domain f of x is equal to negative x squared plus 2x plus 8. Okay, so all I did was distribute. You don't have to distribute like this, you can just leave it in that form. So this is the proper notation for a piecewise function.